All right, let's do a quick review of last lesson. We look at switch statements. So switch and a expression or a value. In case the value is X, do something and then break. Remember the break, very important. In case the expression is Y or equals to Y, then do something else, break, and so on. And at the end, default is if nothing else to do, then do the default thing. And that's it. That's a switch. Okay. And then loops. The while loop is while the condition is true, do the thing and then repeat again. You know, as long as the condition is true, then keep doing thing. So to break out of the loop, then the condition has to become false. That's why inside the loop, you have to change the condition, right? And if the condition is not changed, then it becomes an infinitive loop. That's no good. And then we look at class attributes. So when you define class, you can define number of attributes, or sometimes call it properties of the class. Today, we are going to look at another loop. It's called a do-while loop. Remember the while loop, you check the condition first. If the condition is true, then do something. But in while loop is just do something and then check the condition. If the condition is true, then go back and do another round and then check again. So you see the difference between do while and the while is that in the do while, you execute the code at least once. While in the while loop, the code is run only when the condition is true. So you check condition first. In the do, you check the condition second. The first thing is to run the code first, and then you check the condition. If the condition is still true, then go back and check again, and then go back. If this is false, then stop. Okay, so that's a minor difference. Otherwise, the while loop and the do while loop are the same, but right, they, there's a difference. So the do while do extra loop. So let's look at a example here. Let's say we want to print out that all the numbers less than 5. So in the while loop, this is while loop, right? So you check the indicator. If the indicator is less than 5, then print out, and then increase the indicator, and so on. So you print out 0 through 4. And then if you use a do while loop, so the indicator is 0, so you print out the indicator and increase the indicator and check if the indicator is less than 5. So I believe the two do the same thing, but just different structure. Let's compare. How do we do that? Where's my main? Here. Main. Here. So I'm going to copy both and put that in here. So we have 2 loops. One's a while and one's do while. Let's compile. Let me save the code. Okay. compile. Oh, yeah. See, it's case sensitive. And let's run it. Okay, it does the same thing. So 0 to 4, that's a while loop. And then 0 to 4, that's the do while loop. How can we make them do different things? Let's say we start with 5. And how about start with 10? If I is greater than 5, then we should reduce. And we also start from 10. That's probably the same thing. Yeah, I don't see that. I try to find example that don't make difference, but maybe this is not the right one. We save it, compile. Yeah, it's the same thing, 10 to 6, 10 to 6. So this is the same thing. Hopefully I can find something different. Let me look at this example here. Let's see. So this one, we start with 50. Okay, we'll see the difference. Let me save it, right? Okay, so we only got a 50 out. This 50 out is from the do loop. So what happens is that that's a difference. So in the while loop, we start with a 50, we check the condition, is 50 greater than 85? False. Does nothing. So it doesn't do anything because the condition is false at the initial check. So this while loop does not print any number out. While the do while loop, so we also start with 50. They just go ahead and print out 50 and take one out of 50, that's 49. And then check, is 49 greater than 85? No, then stop. But we already print out 50. So that's the difference. Okay, this is a minor difference between the two kind of loops or while loops. Okay, next loop is called a for loop. I think we already used for loop, but we didn't really look at it here. So in the for loop, you have 4 statements. In the while loop, only one expression or one condition, but in the for loop, you need a semicolon separated statements, 3 statements. So normally the first one is declare or initialize a indicator. Let's say we start with I equal to 0. And the second one normally is a condition, just like the condition in while loop. So basically, okay, start with 0, set I to 0, and check the I if I is less than 5, and then increase I by 1. But this increase happens when I think, let's see, after the code, I think. Let's find out, because sometimes I forgot. Let me again compare the two. Okay, compare. Let's try first, and then I will explain. No, got an error. Why? Why? Okay. Let me see. Variable is already defined. Yeah. Because the I is already defined here, and we cannot, redefine it. So maybe just delete it. So that should be fine. Yeah, that's fine. And clear. Okay, 0 to 4, 0 to 4, no difference. So, yeah. So for I to 0 and I is less than 5, then print on I, and then, oh, remember the I plus plus, that's a post increment. That means a impact the next loop. So that's why when you print I, it don't print, the first is not a 1, it's a 0. So they print basically the initial value, and then add 1, come back, that's the I is 1, and then they print out 1. And then 1 plus plus, that will impact next loop. That's why, yeah. So the two, they both do the same thing. Okay. Okay. Next example. Any difference here? Oh, yeah. If you want to print every other number, not one continuous like 1, 2, 3, 4, 0, you can use actually. You can increase the indicator by a value more than 1. If you want every other, then add a 2. If you want to skip 2 numbers, then you add a 3, something like that. But this is rare. Normally you want something like continuous number, but this is legal, but it's not. It's less common. It's less common. Again, delete that one. Yeah, so you print out, first is print out 0, you add 2, print 2, 2, 3, 8, 10. And same thing as here, 0, print out 10, and add 2, and all the odd numbers. Yeah, if you want to print out this is all the even numbers. If you want to print out all the odd numbers, you can start with 1, and then, so that's the odd numbers. Let me see, how do we do that? Yeah, I didn't change the first. So first print all the even numbers, and next one print all the odd numbers. Okay. Okay, let me check the time here. It's good. Oh, and for each, and then we have this for loop. And also we have for each loop is for the arrays. Have we looked at arrays yet? No, we haven't. I think the next lesson. Next lesson we will look at arrays, but array basically is multiple values assigned to a variable, and then you use a type, whatever type, a string or int or double, and then there's a square bracket to indicate that this variable will hold not a single value but multiple values, or a array of values. So for example, I have a variable called a cars to hold different car brands, Volvo, BMW, Ford, Mazda, Toyota, Honda, and so on. So different names, comma separated, curly braces, inside curly braces. So that's called an array. And for each, Well, it's called a for each loop, but actually here is called a for. I think, is that a syntax error? I forgot. Let me find out. I thought it's for each, but maybe just a for. So we have this array there. We want to print out all the individual names. So if you use a for loop, said for car, colon and car, this is array. And the first one basically, okay, take each individual value from the array and then assign that value to a local variable called a car and print it out. Let's see if it does what we expect it to do. Let me compile. Clear the screen. Run it. Oh yeah, it does. It's not a for. Yeah, even though it's called a for each loop, actually it's a for loop. We call it a for each is basically for each element, or for each value is an element. So basically say for each element in an array and print out the element value. So that's why it's called for each, even though it's just for. Okay, and so the casing here is a for, that's keyword, and then this colon. And before it is a single variable, single value variable, and then after it is the array name. Okay. And similarly, you can print out, you know, apple, pear, banana, orange as fruits. Yeah, that's same thing. Yeah, that's same thing. Yeah, we don't have to try that. And also, it doesn't have to be string. For example, to print out the numbers, remember those numbers? We can do something like this, actually. So for that, we can do something like that, to print out the numbers like that, and then we can do this. Int called numbers is a nose numbers. And since the numbers are int, not a string, you don't have to quote. Say, okay, numbers 0, 1, 2, 3, 4. Yeah, or 5, and so on. So you can list that, you know, put the number into array, number array of type int, and then use a for each loop like that to print out. That's going to be int a number from numbers array and print out the number. So this will print out 0 to 5. Let's compile. Yep. So the first one print out the cars. Next one, that's our regular for loop. And this is the for each loop on the number or integer array. Okay. So the same thing. Okay. That's a for each loop. Let me see. Let's look at the class methods. Huh? I think that's the type of class method, not classy methods. Class methods. Last lesson we learned class attributes or class properties. Basically, inside class, you declare some variable and with some initial or default values. Those are called attributes. And then you can also actually, not just attributes, you can add methods to a class. let's say you have a class point. Remember the point class, the class. You can add a method to it called a show. So, and this method can do certain things when you have an object of the class. So in this case is, okay, here's a point. The attributes of this point or location or position of this point is x equal 5, y equal 3. And this method basically, okay, show me the attribute values. And that's this method belong to this class. Okay, they show basically, okay, print out the attribute point equal to the attribute values. Okay, and this is just a class. There's no main method, so we cannot run this program by itself. We have to use another class that's called a draw. Again, the draw, and it has a main method. Inside the main method, we create a point object. This is called a point object out of the point class here. So with new point, and that's a project and save it to object, not project, object to this points 1. And then when we have an object, so that's the object, then we can call the class method show. Use a dot operator called a show. Of course, you can, again, you still can, use the print here to access the object attribute, point1.x, point.1, that's the, the other way to do it. So the show to print out that value, and the print those two lines also print the XY value as well. So either way, sometimes you want to use that, sometimes you want to use the method of the class itself. So that's called a class method. Let's try it. Okay, so yeah, in this point class, we added the show method. Okay, and then in the draw class, we create this object and use this, since we have this object, use a data show, then call the point class method and print out XY value, or the position or location of this point. Okay, and let's try that. Now you can compile multiple classes again, point Java and draw Java. And you should have that and that. So we have those two classes. And when you run again, you just call the one that has the main function. If we do that, we should see something like, yeah, there. Point equal to 5, 3. Point is, yeah, 5, 3. That's from here. So that's that. This call, do that. And those two, that regular, the direct attribute access way and print out those two values. So they do the same thing. Let's see what else we can try with class method. Huh. Yeah. You can have multiple methods in a class, and also you can have the same method but different parameters or arguments. I think we learned that that's like the method overloading. Yeah, here. The method overloading, basically you can have the same method here. You can have the same method, but a different arguments. In this case, it's just the same number of arguments, but different type. And in this, between these two methods, they call the method signature, same method returns same type of result, but one with no arguments and another one with 2 arguments. So the difference is that this is called a method overloading. Overloading means that, hey, normally should one method do one thing, but how come you got 2 methods doing different thing? But this is allowed. So when you call addition method without arguments, it takes the default value, xy, default value here, xy here. When you call the addition with two parameters, see this x is different from this x. So because this x is local to this method only. This is a little bit confusing, but this is allowed. So this is a local here. So that's why this one is different. Of course, to make it less confusing, you can call it something different. You can call it, double A or double B and return A plus B. Yeah, that's less confusing. But when you get used to it, you think, oh, that's fine. I know this is a local XY, different from this. This is called a global, or not a global, or this global to this class. But these X and Y are only within scope of this method, just within those 3 lines, okay? So just make you more confused, but this is allowed, this is totally okay. So when you call this one without argument, it will take 5 and 3. When you call this one, then you have to specify the 2 values you want to pass, or you want this method to act on. And then we have this deduction, like x minus y. So again, without arguments, it take the xy here, take 5 and 3. And here, when you have arguments, it takes the x, y here, just do the minus. And so on. So you can see that you can, for a math problem, you can add, division, multiplication, modulus, and other power, square root. You can add more math functions here. But I just picked 2 to show the idea. And that define the math class. But to use that math class, let's say we can create our own little calculator. And in the calculator, we have a main function. We create a math object first, use a new math class that create an object. And in the object, you can call the addition with a parameter that will return 5 plus 3. That's 8. So it will print 8. And the second time, we will call it with 2 parameters. I say x is 25, y is 35, and do the addition. That should return 60, right? 25 plus 35, that should be 60. And similarly, you can call deduction. I didn't use the default one without arguments, but I just went ahead, passed 2 values. That should return minus 10. Let's verify that. Let's see, math. I believe I have entered math here. Oh yeah, I entered the math here. So we have the math here. And then we have the calculator. Oh, something wrong with calculator? No. Yeah, so we have the calculator. So first we have that new object, and then we call that, and we call that. So Yeah. Condition first time, condition second time. Let me see. Clear. Java C. Math. Java. Calculator. Java. And then we should have those two classes, math class and the calculator class. And we want to, when we run it, we want to run the calculator class. Yeah, so the first one, take the default value, that's 5 plus 3, that's 5. And second time we print, we call the addition with 2 input values, that's 60. And for the deduction, we pass 2 values, so that should be minus 10, right? So that's pretty neat. So can we add something else? Yes, let's add something else. Let's add another method called division. And that's pretty easy, just that, right? Or is how you define the function. So public, so you can use it from another class. That's the return type. You want return type. If you say, hey, I don't care about the double, I only want the integer part, then remember xy is double. This is double, then you have to convert the double to int. You return, you have to do that. Okay, that's a division. Okay, we have division now. Then let's save it. Then in the calculator, no, that's not calculator. In the calculator, you want to a division. You will say, okay, that divided by that. No, just use that. Let's see what happens. Do you see the problem now? Let me. So public int division. I do that. Now there's a problem. Let's see if the compiler or the compiler can catch it. Okay. The error is incompatible types. Possibly lousy conversion from double to int. Lousy, Lucy. I don't know, Lucy. Yeah. So we convert from double to int, and here, so not here actually. Oh, the here is the z is still double, so we probably want to use int. We cannot use z anymore because z is double. Or use we ran out of x, y, z's. No, we can now can use x. X is available here. X is used in the other class, but not in this class. So X is okay. So we want to capture the int value the return result. Let's see what happens this time. And maybe it still complains. No, it doesn't. Oh no, that's just wrong. No, that's not compile. I want to compile. So it's still complaining about it. So it's not here. It's in the mess. Possible lossy conversion from double to int. So maybe it's doing something like this. Maybe it doesn't know is convert X first or convert the whole result first, last. Let me try that. Oh yeah, now it's okay. So basically, without that, is confused. Well, what do you mean? You convert X to int, but then divided by double, then the return type is double, but you want to capture int. So the conversion is not clear, not accurate. So you want to do the calculation first, because the division take doubles. Do the calculation first and then convert the result to int. So that's what is expecting us to do. So compile it again. That's good, no error. And it's wrong. Calculator. Yeah. Okay, then 25 divided by 35 equals 0. That's because, yeah, it's a 0 point something, and then we just want to keep the integer part. That's why we only get a 0. So, programmatically is legal, but functionally, obviously, that's not probably not what we want. When we do a division, we probably want to keep some, decimal points. So let's just put back to double, and then we don't have to do any conversion, right? We don't do anything there. And back to the main program, then, yeah. Don't use int. And put that into, say, z, double is z here. And save it. Clear. That's better. Look at that. Division. Well, you may think, wow, that's too many decimals. But I think later on we will learn how to trim the decimal points. Let's say I only want to keep two decimals. Like if I want to calculate percentage, probably only 2 decimals is enough. I think there's a formatting thing. Let's see if we have time to try look at that now. Yeah, I think we have a few more minutes to try that. We will learn that later, but why not try that now? So when you do the thing, you probably want to do a format thing. Let's see if I can figure out real quick. You probably want to do a formatting thing here. The first part is a string, and the second part is a double, but with 2 decimals. The 4.2 and a comma and a quote that. Blah, blah, blah. No, that's a string. I may need to look up something. Oops. Yep, something wrong here. It's not the right print function to do. Yeah, print line probably doesn't take formatting. Let me do a quick lookup. W3 school. No. Java print, probably printf. Printf function. Oh yeah. Yeah. So is if you're a static string, you just type that and then the value. So what that mean is, oh, this is PHP? No. I thought we are looking for Java. Java string. Oh, here, yeah. So I think it's similar. It's really similar. There's F. So what that means is and the value here is I think is to F probably. Let's try that. Still error. Oh, of course. We want to use F, not a ln. Print F. Printer with the formatting. I think a printer with formatting, that's got a print F. Better. Let's see what do we got this time. Oh yeah, great. Look at that. Oh, now the command line is next to the value. That's because we need to add a new line. So basically, you know, print something on a separate line. So \a means new line. I save it. Compile. Not clear. Just run it. There we go. So what we did here is, okay, printf, we know the string, static string part, you just put it here. And then this formatting is the percent sign that to indicate it is a formatting. And you format a float value, and the total length is, you know, up to 4. And among the 4, you know, the 0.71, that's 4 letters. Then 2 of them are decimals. So that's 4.2 means what 4.2 means. So they got, you know, that instead of that long, very long number, you only keep 2 decimals. If you say, oh, my number should be 10, you know, 10 characters long, or like, you know, very long, but only 2 is decimal, you can put a 10 there. You still get a .71, but in front, it will pad with spaces because you don't have that long number. You only have 4, but let's try 4 anyway. Yeah, see, you have 4 here, and then you add 6 spaces in front, like a 6, 1, 2, 3, 4, 5, 6. Yeah, you added 6 spaces in front. So this is a formatting print function. It's very interesting. This is good when you build a table, you know, have different columns of different widths or sizes of data, and then you want to use a format them, to align them well. You do need this function and then different way to format it. We will probably try more of this in the future classes. All right, I think wow, it's 49. Sorry. Any questions?